Bismillahirrahmanirrahim. Assalamu alaikum. Iyyaka na'budu wa iyyaka nasta'in. Today, the topic of our discussion is all about diversity and magnitude of organic compounds. As we go through the topic of organic chemistry, so over here we have to focus that why organic compounds are such a large amount in our society, and for this we come across to the four different type of categorization that around 118 elements are known today, but the number of is more than 10 millions. This number is far more than the number of all the remaining elements taken together, and the basic reasons for existence of such a large amount of organic compound is catenation, isomerism, strength of covalent bonds of carbon, and multiple bonding. Firstly, we go through the topic that what catenation is. So it's basically an ability of carbon atom to link with another carbon atom either by means of single, double, or triple bonds to form long chains and rings. And the basic, we are having that example that in first case we are having the example of octane, and all the carbons are singly bonded with another carbon atom in a straight line. But in second example we are having two benzene rings. They are fused together in the structure of naphthalene, and here the carbon atoms are linked in a form of a cycle. And third example is that of cyclohexane. So again the carbon is linked with another carbon in a form of rings. Whenever we are considering the process of catenation, the element should exhibit two conditions to fulfill the phenomenon of catenation. Number one is that element should have a valency 2 or greater than 2. Second foremost important condition is that the bond formed by an element with its own atom should be stronger than the bond it formed with another element, especially oxygen. So in case of that, we consider the comparison between the silicon, carbon. As carbon and silicon, they present in the same group, that is group number 14, and carbon can catenate while silicon does not, and mostly silicon appears in the form of silica or silicates in nature. The basic reason is that both are present in the same group, they are sharing the same electronic configuration, but and both are tetravalent, but the second condition is not completely fulfilled by silicon, and carbon strictly fulfill the second condition, which is related to the strength of the bond. So carbon-carbon bond strength is about 355 and carbon-oxygen bond strength is about 351, in which carbon-carbon bond is much stronger than the carbon-oxygen bond. But in case of silicon-silicon bond is about 200 kilojoule per mole, while silicon-oxygen bond is 452 kilojoule per mole. In that case, silicon bond is much weaker than the silicon-oxygen bond. So though both are tetravalent, but silicon failed to prove that the second condition of catenation, thus it most likely to appear in the form of silica and silicates. Second most important phenomena which helps to give such an abundance amount of organic compound is isomerism. Isomerism, or the isomers of the compounds which possess same molecular formula but there are different arrangement of atoms or different structure formulas are called isomers, and the phenomena is called as isomerism. When the number of the carbon atom increases, obviously the number of isomers also increases. So in case of butane, the isomers basically start from butane, methane, ethane, and propane. They doesn't possess any sort of isomers. The possible number of isomers in case of butane are 2, pentane are 3, hexane possess 5 isomers, heptane 9, and octane carry more than 9 isomers, while nonane 35 and decane 75 number of possible isomers are there. As far as the third important criteria is concerned, that is related to strength of covalent bonds of carbon. So carbon being having very small size, carbon is forming very strong bonds with hydrogen, oxygen, nitrogen, and halogens, and enable it to form the long number of carbon atoms. As you consider over here that mostly hydrocarbons are the bond between carbon and hydrogen. So the bond energy which is required to break the bond is 413 kilojoule per mole, and in case of carbon 355 kilojoule per mole, carbon nitrogen is 293, carbon oxygen is 351, And likewise, carbon fluorine bond is 485 kilojoule per mole of energy is required to break the bond, or you can say that such a amount of energy is released when that bond is formed. Likely you are having carbon chlorine bond, which is 328 kilojoule per mole, carbon bromine, which is 276 kilojoule per mole, and carbon iodine, which is 240 kilojoule per mole. From that you can imagine that carbon is having a very strong affiliation with other atoms, and it is sharing a very strong bond with them. So this is another reason. One of the fourth basic reason is that carbon, though carbon is tetravalent, but it can form multiple bonds. Like multiple bonds means, okay, in most of the examples we see that carbon shares a single bond with another carbon atom, but there is a possibility and carbon more likely form double or the triple bond and forming most possible structure. For example, in case of ethene, you are having two carbon atoms, but carbon can share double bond between another carbon atoms. And likewise we are having the example of acetylene, which is ethyne. Again we come across to the two carbon atoms, but carbon shared 6 electrons or 3 pairs between carbon atoms and forming the 3 covalent bonds. So overall, if I talk about that, organic compounds basically undergo the process of catenation, isomerism, strength of covalent bond, and multiple bonds, which make that organic compound to exist in such abundant amount in our society. I hope this is very helpful for you. Inshallah, we come with a new topic. Allah Hafiz.